Okay, hello, welcome to this video. So in this video, I'm going to talk a little bit about the NIDAQmx GitHub repository that I'm setting up. Okay, so there are lots of things added which I think are unnecessary. Like you see this .usefullinks.un squiggly line and this useful links thing. This is not actually that important. But there are two pieces of code here that are important. I'll probably remove this in a later update or something, but and then put them in some git ignore. I should have put them into the git ignore. But yes, here's the Python NIDAQpy which I was building the last video. So how I structure this code again, yeah, is a class wrapper, the test, and the workspace. I won't explain too much what's going on. I hope you understand. If not, just leave a comment. I'll try to explain. If there are enough comments, I'll make a video, but other than that, I'm not going to do anything. I've actually added something since the last video. It's called print help, so that every time you import this Python NIDAQpy module, you will actually have a nice help message that helps you to know what to do. So let's say there's a test. If I want to load the test test object, yeah, see if I load the test object like that, self.test, and the NIDAQ wrapper object, you will know what to do. It's just import NIDAQ, from NIDAQ import workspace, workspace equals to self, test object equals to self.test, and to load the NIDAQ wrapper object, use this. Yeah, you can just copy and paste the code, or you can just type it in yourself. Next thing I'm including is a site for useful links, where you can find all the useful links you'll see in the YouTube tutorial, whether it's the Python documentation, Python tutorial, the 10 functions thingy, okay, some advanced programming C reference guide. They may or may not be updated. Okay, so I won't promise anything here, but of course I should update them. So okay, two minutes in, 2:34. Let me make a mark here. Yeah, so over here there are examples from the NIDAQmx GitHub repository. So let me put this here. Excuse me. So NIDAQmx Python has a GitHub repository under NI. So it's I guess really by this National Instruments people, the official National Instruments people, and they have their own GitHub. And based on their GitHub, they have a NIDAQmx Python. It's a public GitHub repository, so this is pretty official as far as official goes. They have NIDAQmx examples here, so you can look in under NIDAQmx examples, which is the first link I gave you. Under this part, you can see what can be done. There's some example code which we can take a look, and more examples are always better, so you can know how to code, the syntax and everything. Okay, and then you can try some of these Python scripts out yourself to see what's happening. Excuse me. So yeah, you can see what are these Python scripts here doing. There are a few examples. Even more interesting here is this test suite. Okay, the test suite is under NIDAQmx, and under test. Okay, under test you will have a lot of pretty much every function will be tested. So this actually serves as another suite of examples you can actually take a look at to see how functions are run. For NIDAQmx, you can take a look. Okay, more examples is always a helpful thing, so we can always go through some of them later. Of course, there's a documentation over here, which I don't think is very updated. Okay, So this isn't very much documentation here. Alright. Okay, but there is some sort of a readme installation, and that's it. Okay. Okay, so other than that, they just refer you to a NIDAQmx help, which isn't exceedingly helpful. Okay, it will help you in some of the basic what do you call that? The basic things for NIDAQmx, but in terms of Python coding, I don't trust it that it has that much documentation. Okay, so this is the NIDAQmx Python official National Instruments GitHub repository. You can take a look here, and if you want to take a look at some of the discussions here, they do have it. And some interesting news, NIDAQmx does support Linux nowadays. So this 19 April 2021. It was tried on CentOS 8. Okay, so I don't know whether it works on Ubuntu or anything else. I have not tested it yet, but it is a interesting potential thing. Okay, so that is nice. You can see all the debugs that are working out here. Some pull requests, but I don't expect to be writing code for NIDAQmx anytime soon. Okay, so I think that's it for this video. I'm not going to... Yeah, so... Okay, never mind. Since this video is short, I'm just going to keep going on and rambling. Next part will be... well, let's talk about tasks. And what's important here. Okay, so reason why I was dealing with listing the names of the devices before, using this for device and system devices, we print the device. Why am I doing this? It's because once you know the device name, you'll have to use it as an input to start reading either voltage, temperatures, or whatever things that there is. So so this is under the task, NIDAQmx task part, and then you'll have to add a voltage channel, okay, or temperature channel, or whatever channel. Okay, so usually they will be in this task channel. Okay, I don't know where. Yeah, I don't know where. Yeah, from this documentation, it isn't obvious where this whether this only pertains to voltage, or is there some temperature or something that's involved. Okay, but once you have this task done, okay, after you add the channel, you can just start reading the values. So so yeah, there's this AI channel. I have no idea what AI is at the moment. I'm still learning. Perhaps it's an automated input and automated output. I do not exactly know. I'm just so-called fiddling around with the code. Okay, so yeah, the problem with this thing is that it's a rather manual process. You will need to look for the name of this dev AI0 or whatever this is, and to do that you will need to look in excuse me, you need to look in the modules here, and then you need to key in the names of, let's say, module A, module B, module C, or module D, like manually. Okay, you need to do the module A, module B, module C, and module D. You need to so-called do all of these things manually, so that's quite problematic. Yeah, so thing is, like, okay, what do you do with how do you, like, so-called automate this process? So see, every time we add a voltage, you need to type in a string of what this channel is and what this AI number, whatever this thing is. So that's the piece of data you need to, let's say we just want to add a voltage channel, right? We want to add a voltage channel, and then we want to do this, okay? Def1 AI0. Okay, how do we automate this process without, you know, switching back and forth within the GUI, or even just oopsie, close, or even just using this naming class thingy. All right, how then we'll have the name module A, module B, module C, and module D. Then the thing is that we have to like manually copy and paste. So is it like yeah, is it the most efficient way of doing things? Okay, so probably not. I want to actually find another way of dealing with this. Let's do python NIDAQ.py. Okay, now page up a little bit. Okay, and the thing is that, yes, let's see where we last left off. So I have this I use this device in system devices. Okay, and that will actually print all the devices out. Now I'm looking for something else, okay, to see whether I can, you know, if you take a look at this this section of code within the NIDAQmx test, it's called test channel creation.py. Okay, they're doing the same thing here. Task AI channels add AI voltage channel, which is the same thing here. And what do they fill in here? Okay, they put in this thing called AI physical channel. Okay, AI physical channel. And what's AI physical channel? AI physical channel equals to this Python random choice. What is this? Random choice of X series device and .ai physical channels. Then you have the name. Okay, so what are they doing here? It looks like this X series device is the device which you actually put into this as an input. Okay, and then you go under the AI physical channels, and then you can extract the name out of it. So somehow there is a name attribute which you can extract out under AI physical channels. So I guess you can look at the channels thing, channels.py. Yeah, look at the channels.py, and we'll see whether we can find what we are looking for, the X series device. Okay, X series device. Excuse me. Okay, this X series device thingy. Yeah, X series device AI physical channel 0.name. Okay, so I assume this X series device should mean the device that we are actually putting out here in our Python thing here. We have we see this print devices, and we see system.devices, and then we can just print this device. Okay, so now I want to do something a little bit more sophisticated. I'm hoping to extract the name out of these devices here. So indent 2 spaces back, I'm going to print device name. Okay, I'm going to make a function for that. Okay, system equals to self.system. Okay, because we already built the system. So for device in system.devices, I'm just going to copy and paste all the code here. One thing we're going to do is print the device. Next thing we're going to do is to assume that this AI physical channel has a name attribute. So I'm going to access this AI physical channels. Okay, so print device.ai physical Is that what? Physical chance. Physical chance? Chance. Okay, maybe I'll just put the 0 number and I'm going to put a dot name here. Okay. So if this thing works, then we are in luck, or we are blessed to have this. So I'm going to try the dev test print device name, and I'm going to do the same things. I'm going to delete this and I'm going to copy and paste all this code. So shift visual yang and paste. Okay, and I'll have a NIDAQmx object. Then I can do print device name. Okay, so print device name will be over here, and if everything works out, we should be able to see both devices and their device names. Okay, I don't know whether this will work, but let's load the test object again, and yeah, so when I load the test object, that should actually do all the reloading for me. Yeah, get test object will reload everything for me. Hold on, did I do a proper test? Self.get test object. Okay, so I think I'll need to just do something here. Get test object, and so I wanted to use the workspace things, but I did not quite get the workspace things done properly. So get test object and get NIDAQmx wrappers object. Okay. Get NIDAQmx wrappers object. Okay, this is just editing the help. Okay, so let's try to run the second test. Okay, what I was doing is to make sure I'm using all the workspace functions here to reload all the classes and modules properly, so that when I change the code here, it will, and I can update it inside this Python console by yeah, I can update inside this Python console by just doing this self get test object right here. Okay, so test print device name. Let's see what happens. Oh, okay, maybe I'll have to do test object. Okay, all right, so we take a look here. Most of the things are okay. So we have this thing here, this module A AI0, which is great. Okay, this is what I want to see. Module A AI0, module B AI0. This is the channel number 0, and that looks exactly like what we need to put in here as a string. Of course, we need to give the thing a string and put it into our NIDAQ. So yay, thank God. Yeah, there is a solution. However, it doesn't always work. As you can see here, says file std in blah 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 print device name. Okay, it says that is some the index is like out of range or something like that. So so not every channel seems to have a physical channel number 0. Okay, so instead of a physical channel number 0, maybe we'll just print let's see whether we can do print AI physical chance. Okay, maybe we'll just do that and you'll see what happens. You'll get the test object and test object print device name. Oopsie. Test object print device name. Okay. Okay, so okay, when we do the AI physical channels, it will just be a physical channel collection object. Okay, so I guess they tell us what kind of object this is, which is the AI physical channel collection object, and based on that we can actually, I guess, take a look here. NIDAQmx task channel collection. We can take a look in this place here. And then we can look at the attributes and whatever we have. So this is like debugging, and they have this list here which is called channel names. Okay, channel names is great. I want to see what all the channel names are. So this is this looks like an attribute. Okay, okay. So it's a channel collection object. Let's see. AI physical channel collection object. So this should fall under here. Okay, so there is a physical channel. Okay, AI channel collection, AI channel collection. Okay, let's take a look at the syntax. AI physical channel collection. So this looks like a more specialized version of this, which I guess it in fact has a sort of what do you call that? There's some inheritance going on here, I am guessing, from the way this thing looks. And there's a lot of documentation here. It's a very long thing. So there is voltage, force, pressure, resistance, even a thermocouple. You are able to take a look at the things here. Okay, so in essence, yeah, I may not know what's actually going on. Okay, and I'm just like figuring my way around. Okay, yeah, this gives us a clue as to what we can do next for printing out the names of printing out names like this, and this is exactly what I want. You just need to find out which physical channel actually works. Okay, if you talk about a list or whatever, yeah. So I guess we can use a for loop to iterate through all these physical channel, and then we print the physical channel name. And that could be one way to access all the names of the physical channels that are available, instead of having us manually do some guesswork over here. Okay, so I'll stop for now. I will try to figure out behind the scenes all this video, and then I will update you what actually happens in the next video. Thanks for watching.